Right, so I'll probably carry this up because I'm the gateway between a talk and pizza, and I'd hate to get in between you guys and pizza. So it's a bit of a whirlwind tour about where JustGiving, the journey JustGiving took to follow some sort of continuous delivery patterns over the last 2 years. So effectively, we've kind of done a lot of work. We jump on the microservices bandwagon. It's been kind of quite eventful. A lot of this stuff is really what we did sort of 12 months ago, and had a chance to mature it. And if I get a chance, I'll talk about some of the things that went wrong. So a quick snapshot of JustGiving. We turn over sort of 400 million a year, that or thereabouts. And I suppose the important thing for perhaps this talk is we operate about 1,000 nodes between our dev staging and prod environment, just to kind of give you a rough idea of where we're at. So, okay, that image didn't come up. So there's a teenager who sadly died about March the year before last, and that was 3 months after I joined JustGiving, and his situation went massively viral. And up until that point, JustGiving had always kind of had fairly known traffic patterns of London Marathon, lots of people would donate. And the Stephen Sutton situation hit Facebook, hit Twitter, hit the news, and we had this tidal wave of traffic like we'd never seen before. And the hosting model they had up until that point had been a managed hosting solution, not a very large company. And effectively, the way they scaled was they phoned up and said, "Can we have another server, please?" And a couple of hours later, a server would appear. So when the Stephen Sutton situation happened, they were on the phone to the hosting ops team on a fairly regular basis, and they were effectively copying and pasting our Monolith web servers pretty much as fast as they could do it. And we had to start powering down dev, and we powered down our staging environments. And we just heard that a well-known TV celebrity whose name is Stephen Fry was about to tweet about it, and so we phoned up and said, "Look, give us more power." And they actually went, "No, that's it. We have nothing else. You've got every single ounce of capacity we have spare," which was a kind of butt-clenching moment for us, because it was like, oh God. Luckily, he didn't end up tweeting about it, and the sort of traffic died off. But it certainly drove it home for us that the hosting and scaling solution we had in place was no longer fit for purpose, and that JustGiving had kind of grown up a bit. So that's kind of setting the backdrop of where we started. So when I arrived, there was a sort of monolithic architecture. JustGiving's been around for sort of 10 plus years, so it's got all the nice .com legacy that a lot of the large .coms have got, who've been around a while. And the developer pain threshold was extremely high, especially around the branching and releasing. And in all fairness to them, I used to work for a rather well-known online domestic rail retailer, and they couldn't deliver this ship code this quickly. So they were doing a lot of things right, but the build times were long, and all the pain that came with it, we kind of felt like we needed to do something better. So we decided to look at microservices being the unicorn which was going to solve all our problems. It's the magic gravy train that everyone can jump on. But then there's a big question of what is a microservice, and you could probably argue for many hours over beers about what is and what isn't a microservice. But in our context, it's a thing that tends to have one purpose and is small enough to reason about. Is it 10 lines of code or 1,000 lines of code? To be honest, it depends, and we're not particularly precious about that. So, knowing that we were going to go down this path of microservices, there was also a realization that actually we needed to kind of look at this whole infrastructure automation thing, being another bandwagon that, another trendy thing that's worth looking at. So we decided, obviously, we wanted to host in the cloud. We looked at Amazon, mainly because one of the guys who just started was like a big Amazon champion, and he had the loudest voice, and we all kind of went, okay, that seems like a good idea. And we also kind of went down the path of kind of looking at microservices as independently deployable entities rather than trying to sort of bag up many microservices together. But obviously we still had this monolith, so we kind of took the approach of, rather than a big rewrite, that we just kind of get the scissors out and slowly chop out bits of functionality along the way. And to be honest, we're still there, and probably will be for another year or so. So when we set out to do a lot of this stuff, we came up with a few principles, the most important of which perhaps was the idea that we'd be very available. Sort of high availability seems to come at quite a cost and a lot of technical challenges. And often, a lot of our services, if they weren't there for 5 minutes, it would be annoying, but with queuing and resilience elsewhere, actually we're pretty resilient to a lot of scenarios. And also, as soon as you start looking at the high availability enterprise licensing models for lots of products, they start to become wallet emptying. So we kind of donned this idea of very available, and we can survive a few reboots or a little bit of downtime without it being too much of an effect. We wanted to make things repeatable, and then we were trying to work out what this whole DevOps thing means, and I'm still confused, if I'm honest with you, but our definition at that time was that actually we just wanted to outsource building the infrastructure to the developers. They kind of have an idea of what they need. We didn't want the ops team to be a bottleneck, and so that was our interpretation of DevOps. And also we wanted to make sure that our environments were all isolated, so dev, staging, prod, and performance test and so on. But most importantly, we tried to be pragmatic at the same time, and we didn't want any of these rules to override common sense. So what we built was some kind of train tracks for automation to basically allow the development team to self-service their infrastructure. And also, on a sort of InfoSec or more of a security perspective, we were trying to reduce the amount of AWS keys out in the wild. We were loath to sort of, distribute them to all of development. And then one of the benefits of kind of building a set of tools that allowed us to allow developers to define their infrastructure is that we kind of forced some sort of convention-based consistency, and that actually has had quite a profound effect later on by having common names for things like security groups or host names and so on. Actually, when it comes to refactoring and changing, you can write scripts that make assumptions about those conventions, and that was an interesting side effect that actually we hadn't predicted. So we're predominantly in the Windows space. Just out of curiosity, how many people here are doing the Windows thing? Oh, okay, more than I was expecting. Actually, I was thinking like 1 or 2 hands. It was probably more like 7. Yeah, Windows is, to be honest, Windows is a pain in the arse from infrastructure automation. It really hurts. But we are where we are. We've got a huge .NET code base. Not much and a lot of .NET developers. We're not going to sort of choose Java or something at my personal whim. So most of our services are composed into 2 types. Either we have a self-hosted service or a web server hosted service. And the self-hosting service was actually quite powerful for us in that it allowed us to pretty much distribute a lot of our applications in a fairly standard way. And we kind of enforced that all our applications had a health endpoint, and that then, with the obvious benefit of that is it dovetails into monitoring and anomaly detection and so on. So our stack was predominantly made of AWS. We were using Artifactory as a package repository, and we've tightly coupled ourselves to Chef. So another question, how many people use Chef? And then Puppet, Ansible and Salt and the rest? Okay, so it was about 50-50 Chef and Puppet, and 10% the rest, which doesn't add up to 100, but ignore that. So in terms of doing continuous integration and continuous delivery, we use both TeamCity and Go. TeamCity was our legacy implementation, and there was too much politics with trying to get rid of it, because developers kind of liked it from the build and unit test side of things. So we kind of left that there, but predominantly we're using Go CD as our sort of user interface to shipping software into production. And there's a thing called Chocolatey, which is kind of like Yum stroke apt-get, but not nearly as good for many reasons, which I could tell you about, but time's short. So our hosting architecture, actually, we went down the path of every single microservice has a green-blue deployment, and each one has its own auto-scale group. Each one effectively can grow and shrink on its own. That allowed us to scale different parts of our systems as the need arises. What it does mean is that you end up with a staggering number of nodes, which was a kind of choice that we decided to make, basically because Windows doesn't have containers. I think if the container space existed in Windows, then we would have probably gone down that route. But for us, kind of organically, we ended up with Varnish sitting in front of most of our RESTful services, and that ended up acting as a load balancer. With the benefit of hindsight, we're probably going to remodel that because we've ended up with quite a staggering amount of Varnish rules for a lot of our services. But the ability for developers to actually independently ship a particular microservice into production and have the safety net of being able to roll back to a previous version pretty much with one click has been quite powerful, and kind of eases some of the testing burden that we could have had if we tried to package a lot of things together. So effectively, when you're creating a microservice, it has all of these things to itself. Probably the most interesting of note, I guess, for me, is that each microservice has its own Chef cookbook. So I was saying that we're quite tightly coupled into Chef. We're actually using Chef as the mechanism for deployment, just as much as we're using Chef to configure the servers themselves. So with the philosophy that our application is no different to installing any other part of the operating system, or MySQL or Apache or whatever. Our application is just another versioned bit of software. We also tried to ensure that we had an operations runbook for every microservice, and that actually has failed because developers really aren't that interested in that side of things, and we didn't have a big enough stick to poke them. But it's definitely something that we want to kind of improve on. So we did a chunk of automation around bringing up a new service, and effectively we managed to fine-tune it down to sort of a developer being able to take a blank Hello World application and get it running in production in probably around about an hour. Essentially, they just need to think of a name, create a Git repository, use a template in Visual Studio, commit that, copy and paste a couple of pipelines in Go and TeamCity. And then the bit I'll go into now is that we've got a little blob of JSON that allows them to define their infrastructure. So essentially for us, the pipeline kind of working from top to bottom, we've got Git, TeamCity actually does the compile and unit test stage, and the outputs of that go into Artifactory and Chef. And then we're using Go as a mechanism for deploying between dev staging, prod, and our sandbox environment. So as you go through this pipeline, the output going into Artifactory and Chef are both versions stamped the same. So there's a cookbook for Chef that tells you, how to deploy the application, travels along with the actual package itself, and they both have the same versions. So for managing AWS, we basically did a load of work year and a half ago, and we started treating AWS as a Chef resource, just like any other resource that Chef looks at. And actually, that's been quite powerful for us. So on a regular basis, we try and converge AWS to meet the configurations that we've got defined in code, and we use that for all our infrastructure, not just for our microservices, but any, if we've got a Graphite cluster or Elasticsearch cluster or whatever, we're using the same approach. And effectively, we just kind of have a blob of JSON that kind of abstracts all the Chef logic. So it makes it pretty easy for a developer to kind of choose what kind of service they want, how much capacity they want, and so on, what site instance sizes, and so on. What's our time? 1 minute. Okay. I'll tell you what. I'll just leave it there. If I've got 1 minute, I'll just leave it there. Yeah. Hang on. Questions? There you go. Any questions? I missed out on the juicy bits, but never mind. There you go.
Oh, shame about that. Okay. Well, cool. Thank you very much for coming.